So, okay, I'm just. So actually, I got the task from David to prepare a presentation about saving. So let's see one of the cases where actually we are talking about saving for the enterprise Ethernet infrastructure. So the task which we are facing frequently is when are we building a new LAN? So new LAN is usually building when you have a new buildings, when we are restructuring or renewing existing buildings, then when the network inside has to be extended, or when the network inside of the enterprise is not sufficient for the new services. So practically what has to be done in that case, it's to build a new, performant, robust, secure, long-lasting and scalable network which is easy to maintain, and it's also ecological. It's pretty, let's say, heavy task, but it's not the only one. In the same time, actually, we always need to keep in mind that it has to cost as less as possible. It should be as quick as possible, and then it should, let's say, save us money also in the future. So practically, when we are talking about building of the new LAN, we are talking about saving. And as I said, when the new LAN infrastructure is planned, actually the saving is important point, but without making compromises. So that means that we need to save resources as much as possible, but actually to provide more bandwidth for the services. We need to save energy, but not to lose the capacity of the network. We need to save environment, but in the same time increase performance and processing power. So we need to save our network from the influences, interferences from outside, so to make it more secure. But in the same time, without increasing too much complexity, because increasing complexity means increasing cost. Then it's always good to have to save the space, so not to have a huge ducts with a lot of cables everywhere. So, and then you know, in a lot of the enterprises, actually one of the important points is to have a flexible layout. So imagine, you know, shopping center or supermarket or open space enterprises. In that case, quite frequently they are changing network layout. So it means that topology should be, let's say, very flexible. And then actually the complete management of the local infrastructure should be as simple as possible, as cheap as possible. So practically, we are coming to the point of the topic of this presentation is, again, save money, and we need to save money now, so it means of the capex when we are deploying a new network, but in the same time also during the exploitation, so also in the future. So that's the homework which I got from Diode to prepare for this. And I will talk you about the FiberLAN. So FiberLAN is, as the name is saying, optical LAN or passive optical LAN solutions. So when we are talking about FiberLAN, so that's the slide which describes it the best, let's say. So it means bring more bandwidth in a secure way with a flexible topology, with robust devices which are consuming less and which cost less than normal. So like ideal case. So what we are talking about, let's start from the points which I listed at the beginning. So first is save resources. So how we are saving resources? But actually this is one of the key innovations which FiberLAN is bringing into the LAN infrastructure. It is introduction of point to multipoint in the network. So, you know, classically every switch port is connected with the end Ethernet devices. So that's a classical structure which is in the enterprises forever, you know. what we are trying to introduce is actually from a single port of the switch to connect multiple endpoints. So this is point to multipoint. Actually, this technology operators are using from the beginning, but this is a new thing for the LAN. So it means like I'm saying, showing here. So to start with the fiber, split it with a passive optical splitter, and then having different ONTs with a multiple number of ports. This is way more intelligent way of sharing resources, actually, because in the case of the classical LAN, so if the 1G, for example, going to that PC is not used, in that case, that bandwidth is wasted. In the case of point to multipoint, actually, if one ONT or one PC is not using the bandwidth, all others can share this. And the bandwidth available is much higher. So it's 2.5 gigabits. So that means a saving of the resources. And actually, the cost of such solution is way cheaper than having for each Ethernet device one port on the switch, whichever it is. This is also, let's say, spreading, network connections. It is also giving, let's say, topology which is more distributed. And then in that case, we are avoiding bottlenecks. Because classical switch infrastructure is having a switch, access switch, then aggregation switches, etc. And every one is connected with a higher level, let's say, of the switching. In that case, you have bottlenecks. Those connections between switches are bottlenecks. In this case, this is way more spread. So practically with the less resources, we are getting more bandwidth. And if we do, let's say, simple calculation by dividing the available bandwidth by the number of the Ethernet devices connected, so if you just divide that number, actual bandwidth is at least 10 times higher. So real bandwidth that each of the connected devices could have. So saving energy, how we are saving energy with such solution. So that's a second important point with the FiberLAN is to arrive with the fiber as close as possible to the connecting end Ethernet devices. It means that not anymore like in a classical case, have just fiber in the vertical and then copper cables in the horizontal, but to extend fiber as far as we can arrive. So practically to have it also in horizontal. Devices which are splitting fiber are passive optical splitters, small boxes like this without powering, without anything. So you can count this as optical device. So as a fiber kind of device. So that's how this is saving energy. So important thing is with the copper cables, you pump the energy into the cable in order to arrive with the signal to the distant point. So if the length of the cable is longer, actually more energy you waste in dissipation, so in heating environment, let's say useless heating of environment, just with a scope to arrive with the signal there. So you know that every metal, when conducting energy, it is heating around. So the concept with the fiber, so arriving as close as possible to the end devices, is actually to reduce the length. So the final Ethernet cables to reduce that length. This is saving us a lot of energy because one thing is to pump the energy to arrive with the signal 100 meters, and the other thing, completely different thing, is if you have to bridge just a couple of meters of the distance. It is even, more severe if we are talking about power over Ethernet. So if you have power over Ethernet and to arrive with enough power, to the 100-meter distant device, distant, I don't know, access point or CCTV camera there, it's one thing. The other thing is having this short. So this is actually the key point where the energy, a lot of energy is saved. You know, with the fiber, actually laser and then the light is lost practically minimum, and you can reach up to 20 kilometers. So we are not talking about 80 meters or 100 meters, but about 20 kilometers. Any campus like, you know, enterprise can be covered from a single point, from the single device. This is what I said. It's saving energy, but there is another point. So maybe to come back here. So practically, even assuming the worst case, let's say that our system, because there are OLTs and ONTs, let's say central switch and small distance switches, if they are all in total consuming the same amount of energy, assuming that the same amount of energy as those switches here, there is still saving. Because one thing is to have distributed, let's say, heating sources. So those small switches do not need air conditioning. In majority of the cases, these big switches need air conditioning. So practically heat dissipated around them is quite high, and for that reason, you need air conditioning. So what is the saving here of the energy is also saving on the air conditioning. This is a huge amount of money as well. So then, speaking about environment, this solution is completely green. We can easily say we are certified that this solution is green. Why is that? Simply, first thing is saving energy. Second thing is also saving space, but also there is no electromagnetic pollution of the environment. So fiber is not emitting anything around. Okay. So another good point of fiber, having fiber also in horizontals, is that actually fiber do not suffer from the electromagnetic interferences from outside. So you can deploy fiber together with the power cables, so which is for the copper cables absolutely forbidden. There is no degradation of the performance of the fiber, even in the let's say heavy environmental conditions. Fiber as material is lasting more than 50 years, so without any degradation of performance, while the copper cables you should change more frequently. And then when speaking about this time, so somebody could say, okay, 50 years is a long time, but then there will be new technologies and we would need, you know, to replace this because of coming of the new technologies. Well, that's not true. In the case of fiber, actually fiber, single mode fiber of today can support more than 69 terabits per second. So this infrastructure could support also services in the future. And moreover, this topology of the network actually can support different evolutions of the GPON technology, of the PON technology, generally speaking. You know that on the contrary, with the copper cables, actually there was a well followed evolution, you know, Cat 3, Cat 5, Cat 5e, Cat 6a, Cat 7, etc., to obtain just a little more bandwidth. Here we are talking about gigabits and about terabits, so way more. So let's speak about security. Another extremely important thing for FiberLAN is fiber cannot be tapped, so you cannot spy the fiber. Copper cables, you even don't have to cut it to hear what is passing there. With the fiber, that's not happening. But there are different fiber technologies as well. So you have point-to-point fiber and you have point-to-multipoint. Now we are talking about point-to-multipoint. And actually, you can easily, if you have point-to-point fiber, you can easily cut it, put a very simple, very cheap device, and monitor what is passing there. So practically everything that enters on one side goes on the other, etc. So even fiber cables, okay, cutting them, you can spy what is passing through the network. Point to multipoint is a different case. So maybe to explain to you, downstream for the GPON is a broadcast. So practically all of the ONTs are receiving from the OLT the same content. How the privacy is obtained there? Simply on the physical layer, it's incorporated 128 IS encryption. So practically to each of the ONTs, data flow is encrypted. So others cannot hear what is there. So coming back to spying and cutting the fiber, so if you have to cut it, you will need to decrypt in real time what is passing. That's one level of complication. Second level of complication is upstream, because in the GPON technology, okay, downstream is broadcast, upstream is time-based multiplexing. So that means that each of the ONTs is obtaining a time slot to send the data versus network. This allocation of the time slots is not fixed, it's dynamic, it is changing. When we are talking about allowing other Ethernet devices to use the bandwidth, we were talking about this. So practically OLT and ONTs are communicating constantly. They're constantly changing and agreeing about the bandwidth which is necessary to be used. So you have complete communication constant. That means that actually spying device cannot just pass the traffic, but also has to act as an intelligent device versus OLT as an ONT and versus ONTs as an OLT. And on the other hand, since it is a time-based multiplexing, it is very sensitive on delays. Actually, the complete system is constantly measuring delays in order not to have a desynchronization of the communication. So inserting device on the shorter length is definitely changing, you know, the setup of the network and can be easily detected. This is the main reason why US government a few years ago got the decree to actually, for all government and military applications, they must be on the GPON. And our solution is certified for that. So GITC certification is a military grade, etc. This technology is already in use in the US Army. So with our equipment, as well as we are starting with Israel and other countries, also here in Europe, armies of. So that's kind of a chapter about saving privacy and increasing security with this solution. So maybe to explain, this is, let's say, the most critical slide here is to explain how, for example, we have a classical campus enterprise topology. So after the computer room or server room, you have a campus aggregation layer, so switches which are collecting connections with the buildings. Then in the base of each building, you have building aggregation switches. And then on each floor, you have access switches. Because of the anti-fire, let's say, regulations, most frequently those are doubled. So for redundancy reasons. So our proposal, actually our innovation is remove all of this and replace it with a single central switch, OLT, with completely passive infrastructure, and at the end to have small switches, ONTs. So small switches means 1, 2, 4, maximum 8 ports, Ethernet ports, because the concept is to arrive with the fiber as far as possible. So this means this is completely passive. So you have this device in the server room, and after that, until the tables or the offices or the hotel rooms, you have nothing but passive infrastructure, no power. So what we are eliminating on each floor, we are eliminating, you know, the switch, the patch panel, the room or the closet where it's closed, plus we eliminate air conditioning. Instead of this, on each floor, we have just one or more passive optical splitters. Very small boxes like this can be placed on the wall. So nothing else, no powering at all, no nothing, just a small box. One fiber enters, up to 64 could go out, nothing more. So this is really something new and something which is saving a lot of space. So imagine in the hotels where every square meter is very precious. So imagine not to have those rooms for switches, for communication. So that's extra space that can be used for something else. Okay, this is what I said. Another thing regarding saving space, actually in the modern enterprises, so modern offices or modern hotel rooms, on average you need 4 to 5 Ethernet connections in each room, for example, if we are talking about hotel rooms. So imagine you have, I don't know, 50 rooms on the floor. What quantity of the cables is going from the central point and being distributed in the space? So instead of that, tiny little fiber or several little fibers. So practically when we are supposed to do reconstruction of historical buildings where there are no space for double floors or double ceilings or ducts for the cables, so practically fiber is the only solution. And actually this solution is only applicable there. So the quantity of the space saved there is more than 90%. And don't forget that this is also very costly. So these metal parts, ducts and cables are cost way more than fiber. So about 70% is saved only on cables and ducts. And also another thing is that actually in a lot of design places, our architects' visions are compromised by the necessities of the IT. Somebody has to foresee cables passing or room for the switches, etc. By FiberLAN solution, actually, architects could do whatever they want. So the fiber is not jeopardizing internal design. Flexibility. I said that actually after the fiber can be splitted, and there is a maximum of 64 ONTs connected on the same fiber. But I haven't said that only one splitting level is allowed. Actually, we can make a structure like a tree, and having from one splitter another one. So the only concern is to have up to 64 connected ONTs on the OLT. So for example, imagine that you have now building. So you have your data center in the basement, let's say, and the office is up. Okay, this is a bit reversed here. And then the enterprise is extending. So in the case of the FiberLAN, what is necessary to do is practically not to think at all about active equipment here, but to pass the fiber or directly from the OLT or from some other splitter somewhere to arrive to that building and then extend the infrastructure of the tree and practically place in each room or on the desk ONTs, small switches. So very simple. Also, imagine the case that nowadays you need 4 ports in one office, and tomorrow you would need 6 or 7. Very simple thing to do is just to replace the ONT here, and you have 8 ports instead of 4. In the case of the point-to-point fiber, or in the case of the copper, actually you would have to pass the fiber or copper cable all along until the switch. So that's also giving extra flexibility in changing of the network. Also, when I was talking about flexibility in the network layout, so if you have, for example, a splitter 1 to 16, it's not mandatory to connect 16 outgoing fibers. you can connect only 5. And then in the future, if in that area something is necessary to extend, you can then plug other cables, other fibers as much as you need. So that's another flexibility point. Then this solution is let's say, with the highest level of redundancy. So when we are talking about, there are several ways how redundancy is being done. There is a fiber redundancy, so this is called GPON type B redundancy. So practically from the different port of the OLT, or the different cards, you can pass the fibers different paths to arrive to the splitter. So that is protected. If you cut one, the other will take over, and the switchover time is less than 20 milliseconds, so it's seamless practically, even for video applications. What we developed extra is chassis-based redundancy. You could have in 2 different locations, 2 different OLTs, and then having fibers arriving to the splitters from different rooms. And then again, you have this on the fiber level. If one fiber is cutted, the other one takes over on the other box, and again with a very, very short switchover time. So that's it. So practically summarizing what is FiberLAN bringing is more bandwidth to a single user by sharing resources. There is single mode fiber capacity is huge, and this solution is future-proof. The distances which you can reach with this kind of solution are 20 kilometers. So practically any campus, any university campus, any hospital, any resort can be covered by a single solution. It is saving a lot of space, so up to 90% reduction of the space used on the floors. It is increasing revenue, okay, because this space can be used. I was recently in one insurance house in Milan. On each floor, so it's a big house, it's a big company, and actually on each floor they have 5 rooms, 5 by 5 computer rooms on each floor, with air conditioning, with etc. So that's really saving a lot of space. Then the power reduction, I explain you the concept where we are saving energy. Then solution is the top secure regarding communication. It has very optimized architecture. Architecture layout of such kind of network can cover any case practically. It's a green technology, and then it reduces CapEx and total cost of ownership as well as OpEx. CapEx, let's say on the active equipment, 10 to 30% cost less, just devices, switches. On the other hand, it's more than 70% saving on the cabling. So don't forget, when you're doing calculations of the projects, don't forget cabling. Cabling is a huge cost. And then, since consuming less energy, it's way simpler to maintain. It's also saving OpEx. Saving OpEx a lot. So those are the, let's say, verticals which we are approaching with this solution. So hospitals, hotels, universities, business centers, campuses, casinos, stadiums, things like that, government and military, yes. And then, okay, if you're maybe convinced about FiberLAN, so the question is why Zhone? So why our company is there? Simply, we are one of the leaders in the GPON industry, so both for operators and for the enterprise. In the enterprise market, we are very leader. We practically have no competition there. Our devices are carrier grade, so 5 nines as availability percentage. We have high standards for redundancy, so practically these solutions are accepted by Central Bank of Israel, so for their internal infrastructure. Just to give you idea about that. So we have a different grade of devices, so either big or 1U devices, which you saw before. So different form factors of the OLTs, as well as we have more than 150 types of ONTs, both indoor and outdoor. So actually, you have a wide choice of different models in order to meet concrete requirements of your applications. We as a company have a special focus on the FiberLAN, so we're investing there, we are developing this, we have special features. So for example, ONTs have functionalities like power over Ethernet. So this is one of the savings I was mentioning before. So instead of having power over Ethernet from the central switch, have it locally. So our devices have that. We have special series of ONTs which are industry temperature hardened there. Then there are special mounting and enclosure kits for various applications. On the software side, we have support for access control, 802.1x, then chassis-based redundancy, LLDP-MED for automatic joining to the specific VLANs, etc. Then we also have a specific management system tailored for the enterprise, which is different from the operators. So, and last but not least is a strong reference list. So Zhone is really the leader, and we already have a lot. So this slide, I'm pretty lazy to update it, but there are much more of the companies. Here are just maybe some of the biggest, like hotel chains, Fairmont, Mandarin Oriental, Accor, Starwood. There are also Marriott and Hyatt, Ritz-Carlton, Taj, many. Several universities. The biggest project which we are doing now in US is Atlanta Falcon Stadium. So IBM as our system integrator, big system integrator, is doing a big project, so doing a smart stadium there. So practically there will be connections, fiber connections to practically each seat or a couple of seats with very, very futuristic services. So this is the project on which we are working this year. It's really huge. Military organizations are not listed there. You know why, I guess. Then Zhone is, as I mentioned, certified for such applications, as well as we are one of the founders of APOLAN. This is Association for Passive Optical LAN. So we are together with our partners, technology partners. So for the passive components, Corning, Tyco, so T connectivity, 3M. IBM is our system integrator. So just to give you a picture quick of the devices. So 1U, 3U, 8U, we have 14U as well for the bigger deployments. So really wide range of the products. On the OLT side, as well as on the ONT, just some of the interfaces and some of the use. So POTS interfaces for analog phones, gigabit Ethernet for SIP phones, computers, or PoE video surveillance cameras, or set-top boxes, or access points. So practically, you can connect different devices. If you're interested, we have also nice reference lists and nice applications which are running over our devices. So management system is also done in the way that could be integrated with any OSS or BSS of whatever enterprise. It has OSS gateway there. So that was my half an hour or more. If you have any questions, I'm here to answer to you, but also guys from Diode are quite capable of supporting this. They are both commercially and technically very, very skilled. So I hope I prepared this presentation in the last moment. Actually woke up at 4 o'clock this morning to arrive here. So apologies if my presentation was not so fluid. Okay, happens.